Pam. How you doing, sweetheart? I hope you're having a blessed day. I set up the problem that you had sent to me, that I sent the workout solution. I can tell, I totally understand why you would need to see it step by step. So I tried to pick the parts I thought you would need the most help with. The first thing I did is I set up over here, though I could see you did too. Find the volume of the solid formed on the region x squared plus y squared equals 16. Of course, that's a circle here of radius 4 with a basis of equilateral triangles perpendicular to the x-axis. Okay, so what that means is here is our region, and what we're going to do is set on top of this region a base of an equilateral triangle. Okay, so that might look something like this. Here is the base of an equilateral triangle, and because I'm trying to draw a 3D picture in 2D, it won't look that good, but we're going to do the best we can with it and talk about what it might look like. But here's the base of an equilateral triangle, so notice I would have to make the full equilateral triangle with equal sides, okay? But let's really darken in this base right here. Notice it's perpendicular to the x-axis. Now, I'm going to switch to black for the rest of the equilateral triangles, because I just want you to know this triangle here is going to be this one here. We just took it and moved it. So let's take a look too. Well, what if we had an equilateral triangle here with its base here? So notice on the ends of the circle that the equilateral triangles are really small, right? Over here, right here, there's a really big equilateral triangle, right? And here there's a really big equilateral triangle. Whoopsie daisy. And they connect over the top. So I know that's a really horrible looking picture, but just think of it. Here, look at me here. Just think of it if I took this circle and pushed the region down, the circle down, and I put equilateral triangles, right? So I'm at the start of the circle here, and it's an itty bitty equilateral triangle, right? And then as you get towards the middle, those equilateral triangles get bigger, and as we go to the back of the circle, they get smaller again. So it would almost be like a tent, right, that with a circular base and the sides come up to a point and the point is connected. And what they are looking for is the volume of that solid. So we know when we accumulate areas that makes a volume, and we know accumulation is an integral, okay? So what we're doing then is, because you can see that we are collecting our equilateral triangles perpendicular to the x-axis from -4 to 4, that is the integration from -4 to 4 of the area of the triangle times dx. Now notice the dx has two purposes here. First of all, my change in x, I really am accumulating across the x-axis. I really am changing x. Also notice that a change in x is a little thickness. So what it really is I have this area of this triangle, and it has a little dx thickness. So it really is a volume. It really is a triangular prism, and we are collecting them. So this really is a volume here, and we are collecting it from here to here. So what we have to do is write the area of the triangle, this red triangle, that's the hard part, and then integrating it. It's actually easy to integrate. Notice though that half the volume of this solid is from 0 to -4, and the other half of the volume is from 0 to 4, and it's symmetric. So absolutely, you could integrate right here, you'd be just fine. But it's kind of nice if you know you have to use f of b minus f of a later to have a 0. So all I said is, you know what, if I just took the volume from 0 to 4 and doubled it, I would have the same volume. So I'm going to use this here. Again, the hard part is writing the area of that triangle here. Notice that this 2 and this 2 cancel out. Okay, so before we write the area of this triangle, which is the hard part, by the way, Pam, they wouldn't have this problem on this year's test. They would have it on another one because this is kind of time consuming and you guys don't have much time, but I really think this is important for you to know in your studies later. So let's forget this for a moment. Here's what I need you to remember. Here's an equilateral triangle, okay? Notice that if you drop a height here, right, that you have a 30, 60, 90, and here's what we know about this, that across from the 30-degree angle, this is the smallest side, okay? We know that that was half of one side, so we know that the hypotenuse is 2 times the smallest side. And if we did the Pythagorean theorem, squared, squared, right, to find this side, the side across from the 60-degree angle is the square root of 3 times the smallest side. I'm assuming that if you did the Pythagorean theorem here, and instead of writing small, you put an x, you would find this side is the square root of 3 times the smallest side. We're gonna need this. Okay, let's come on back over here. I need to write the base of this triangle times the height. All right, here's the height. I gotta draw one in. All right, well, the base of this triangle right here is located right here. Right, we took that triangle and put it there. What is the base of this triangle? Well, let's take a look here. If you notice, I'm gonna switch to blue. If you notice, if I wanted to rewrite this equation in a different way by getting the y alone, I have y squared. I'm gonna subtract an x squared from both sides. Here we go. And I'm now gonna take the square root. And I'm gonna remember to put the plus or minus in front of that square root. So what's happening here is this point on this circle is located at some x, and how would I find the y that goes with it? I would put the x right in here. So the y value at this point is 16 minus x squared. Now notice that this y is positive, right? So that's why I have this is positive in front of the square root. Right, this is the top half of the circle. Notice at this point right here at some x, right, how do I find the y that goes with it? I put it in here. So here's the y value. Notice that all of these y's are negative, right? So the top half of the circle for any x is the positive square root. The bottom of the circle is the negative square root, okay? And so how big is this base then? Well, this base right here is this y value minus that y value. That's how long that base is, right? The top y minus the bottom y. Let's go ahead and do that. That's the square root of 16 minus x squared minus a negative 16 minus x squared. We know that 2 negatives make a positive, so this base of this triangle is 2 of these. 16 minus the square root of 16 minus x squared plus another one. That is how long this base is right here. This whole base is 2 times the square root of 16 minus x squared. And this is, because it's split in half, that's 1/2 of the base, and here's the other, and 2 of them make 2 square roots of 16 minus x squared. What does this mean? That base right there is 2 square roots of 16 minus x squared. That's how big that base is. Right there, we just saw that. Okay, so in blue, I can fill in a little bit. All right, we're getting there. this 2 and this 2 canceled out, going from 0 to 4. I now see that my base of my triangle, trying to write this area, right, is 2 square roots of 16 minus x squared. There's the base. All right, I need the height. What is the height of this triangle right here? All right, let's go back over here. We made ourselves a template. All right, let's take a look. Let's see. This height is the square root of 3 times the smallest side. This piece right here marked small. This height is the square root of 3 times the smallest side. Okay, let's see that again. The whole base is 2 times the square root of 16 minus x squared. There's the base. The height is, again, let's look right here, the square root of 3 times the smallest side. There it is, and there is our dx. Now what's really cool about this is, this looks super complicated to integrate, but let's go from 0 to 4. Let's bring our constants together. Here's a 2 and a square root of 3 here out front, and look at this. The square root of 16 minus x squared times itself, the square root eliminates, and now we are just integrating 16 minus x squared, which isn't that nice? Didn't that work out great? So I am assuming from here, Pam, that you would be able to integrate this and do your f of b minus your f of a. Notice, because we have a 0, that you won't even have to do f of a, and that you'll get our final answer of, what answer had I worked out? 2 square roots of 3 over 3 times 128. Hopefully I didn't make any silly mistakes, but I'm hoping that that helps you with the little details. And I miss you, and have a great day.